Welcome to part 6 of our customized custom YT-1300 on Blue Squadron, where we're going to go ahead and install the LEDs for the headlights. What I'm making right now is a 3-wire lead to the dual throw switch on the bottom of the Falcon. That switch is going to determine whether or not the headlights on the Falcon are active, or whether the LED that's in the center of the Falcon's mandibles is going to be active and shine through a fiber optic cable all the way through the escape craft while it's docked. For this set of 3 wires, I'm using JST-PH connectors. JST-PH crimp connectors are smaller than DuPont connectors, so they're a little more difficult to work with. The advantage of these connectors, though, is that the housing does have a clip. In addition to making a mechanically firm connection, you actually can't connect JST connector housings backwards. This 3-wire connection will be a ground selector. The middle wire will be connected to ground, and depending on the position of the switch, either the left gray or right purple wire will be connected to that middle wire. In the last video, we covered how to do fiber optics, so I'm going to time-lapse through this. There's going to be one main headlight LED, with 2 strands going to the left mandible and 2 strands going to the right. To test out the fiber optics, I'm jamming the legs of the LED into a PowerBoost 500C, into the 5-volt and ground connections. Typically, you're going to want to have a resistor in the circuit to prevent the LED from instantaneously burning out. These white LEDs tend to be okay for a few seconds just for testing purposes. The LED is going to have to get soldered to that 12-channel driver. The long leg is going to connect directly to the driver board, while the short leg will connect to that ground switch later. I'm using the Dremel to make a tiny hole in the plastic between the mandibles. This is where an LED will go that shines all the way through the escape craft when it's docked. I thought of different ways of trying to automatically detect if the escape craft is docked using either a photoresistor or some type of reed switch, but ultimately I decided to go for the simple and sure option, which is a mechanical switch. I also didn't want to open up the escape craft to try to install an LED that would somehow draw power from the main Falcon body. The LED that I chose for the escape craft headlight is a 3mm surface mount white LED. They're very difficult to solder. It's best to apply a little bit of solder to each of the pads on the LED with the finest solderer tip that you have. I've seen other modders like LED Hanger use 1mm surface mount LEDs and then solder magnet wire to them. Magnet wire is extremely thin gauge. I just really don't have the eyes or the hands for that. After applying solder to both pads, I tinned the tips of 2 wires that were going to be connected to that LED. Having a small bit of solder on both the LED and the wires means that you can apply a little bit of heat while touching the 2 of them together, and hopefully that means that the solder will melt and then solidify as it cools before the entire thing moves. In practice, it's pretty difficult to do, and sometimes it takes a few tries. The good news is that the second wire is easy to solder once the first one's in place. I'm now going to use angled pliers to bend a 90-degree angle into the connection. This allows the surface mount LED to fit nicely inside of the hole we made and not have too much strain on the solder connection when the wires lead back to the LED driver. So the 3-wire connector with the male side of the housing is going to go to the switch, and the female side is going to connect to the LED ground pins. I'm soldering those wires directly to the legs of the female connector, but that's not really what they were made for. Those legs are really designed to go inside of PCBs with traces where you could probably solder a wire into a different through hole, but I'm going to go ahead and try to connect them directly. I had to choose an awkward position for this connector because both sides needed to be accessible from the front of the Falcon. This resulted in messy solder joints that I had to clean up later on with my flush cutters. Once the ground pin of the central LED was soldered to the left leg of the connector, I had to solder in the other headlight LED. I chose to pass the long leg of the LED underneath the driver board. This proved to be a little bit of a mistake because once I soldered in that leg, I ended up damaging one of the fiber optic strands and had to rethread it. Knowing where everything fits now means that in the future, if I do another one of these customized YTs, I'll be able to solder in the LEDs before threading in the fiber optics. I'm tinning each of the leads on that female connector so that I can solder the other grounds to it. I'll attach a wire to the central lead, and that's going to be the main ground connection to the 12-channel driver. The last unused pin that you see here is going to be for the other LED. Here's where a little bit of planning can go a very long way. I tried soldering that central ground to an LED port in between the headlight LED and one of the targeting arc indicators. There wasn't enough space, so I ended up choosing an open port on the far left side of the driver. But trying to solder the positive lead to the central LED while the fiber optics are already run in place means that I was really lucky I didn't burn my fingers. Trying to solder the ground connection for the other headlight LED meant, well, more bending and more awkward soldering. All of the wire that I'm using is silicone-coated stranded wire. They're resistant to heat, but you still don't want to do what I'm doing, which is operating a soldering iron in an awkward position while threading the needle of a whole bunch of wires that you might potentially melt. After everything was connected, all I needed to do was use some super glue to glue in that tiny surface mount LED into the hole that I made for the central headlight. In the next video, I promise to do a better job when I start doing the connections for the AT Tiny 85 microcontroller, which will serve as the brain for the Millennium Falcon. Thanks for watching!